All right, we're going to be talking about VPC right now, which is setting up your own private networks in AWS. This is the foundational concept for understanding how the cloud works. This is probably the least fun to learn. That's why we're doing it first, but it's what sets people apart from being amateurs compared to professionals. There's a lot of stuff in AWS that's super fun, like I don't know, spinning up EC2 instances and setting up databases and things like that. And those are kind of more development related things. But all that stuff sits on top of this foundation, which is the networking. And the networking is something that you can completely grasp because you took the 404 class, the data comms class, but a lot of developers and people out there in the world are going to run with their tails between their legs away from this initial foundational concept, and they're always going to be kind of weak in their skills because of that. So this is the thing that will set you apart from the other people, and you can totally master this. And this is what would make you a solutions architect compared to, I don't know, just somebody who hacks around with it. You can master this rather than just be working in it and not really know what's going on. Okay, so first thing, log into your console. And by the way, this isn't going to cost you any money. That's one of the great things about all the networking services and firewalls and stuff like that. It doesn't cost any money to do this stuff. So click on VPC, or in your search box, just type in VPC, and it'll bring you to something that looks like this. I've actively messed around with the networking in all of my regions, so I don't know if mine looks completely like the default setting does and yours does at this point. But let's first jump in and look over here where it says VPCs. And there's one in place. And something I want to note here is that it says 172.31.0.0/16. What this tells me and jumps out to me and tells me is that there are 65,536 IP addresses that I can allocate to services like EC2 instances that I could spin up in this network. Now, VPC is kind of like the big catch-all net for all of your networking, and then you further subdivide it with subnets. So you start off with your high-level network, which has a whole lot of space in it, and then you're going to subdivide it. So let's just say 65,536 IP addresses. Let's just say I want one subnetwork for my web servers, and I need 1,000 in there, and then I need a couple of databases, and I need 5 in there, and maybe I have some other applications that I'm running for back-end services, and I need 100 servers in there. I can subdivide this thing up into 3 networks or however many I need, and then some of the IP addresses in this range go to one subnetwork and some go to another. So by itself, this isn't directly usable. We have to further subdivide it into subnets. Okay, that's probably enough to say about that. Let's go ahead and have you follow along with me and pretend that we're configuring our account in a particular region to set up for development. So, or actually just running our company from beginning to back. So I'm going to click on Create VPC, and let's assume that we're going to have a network which is for our production web servers. So there's going to be people out in the world who are going to be interacting with our web applications, and so let's call this production. And the largest that we can make our CIDR block, and by the way, these are the RFC 1918 address ranges, so you can do the 10s, the 172s, or you can do the 192.168. Any of those 3 work, and then you can do /16 to maximize the number of IP addresses that you can have in there, or you could make it smaller. I think 28, which would give you 2 to the 4, or 16 slots, I believe is the smallest you can make your network, and 16 is the biggest you can make your network. So you do 32 minus whatever this number is, but this number can't be any smaller than 16. And that number that's left over, in this case, 32 minus 16, 2 to the power of 16, gives you the number of IP addresses that you have. Or if I was doing 28 is the number here, then 32 minus 28 would give me 4. 2 to the power of 16, 2 to the power of 4 would mean that I have 16 IP addresses that are going to be available, and these are private IP addresses, not public, that are available in my private network. As a recommendation and best practice, you should just always make this as big as possible. There's no reason to make it smaller, to be honest. And I'll go ahead and click on Create VPC. You do the same. All right, and let's go back to my, well, I'll go ahead and click on your VPCs over here on the left. So now I've got one called Production. Let's go ahead and create another one. And I'll call this one Development. So all my development work is going to be happening there. And I can make it just as big. Probably not going to have that many computers running in my development environment, but hey, why not? Let's do it. Okay, click on your VPCs again. And let's create another environment we'll call Testing. And just to show you that I could do something different, I could do 172.32.0.0/16 as well. And click on Create VPC. All right, so now I click on your VPCs. And what I have allocated now are 3 different things. And let's see if I can scroll over here. See if it tells me anything interesting. Well, nothing too interesting at this point. But notice how I can reuse the same address range. So even though it looks the same, these are, because they have a different ID associated with them, these are physically separate networks from one another, or logically, virtually separate from one another. They don't overlap even though they look like it. Okay, if I go back to the dashboard area, the highest level thing of all, this catch-all net, is a VPC. A VPC is a place for me to allocate a bunch of IP addresses within a given region of AWS's cloud. So I could spin up 5 VPCs in Virginia, 5 in Ohio, 5 in Oregon. And if I was a really big company, I could just say, hey, increase my service quota and give me more VPCs available that I can allocate. Okay, and then what I mentioned before is we typically allocate or subdivide our network. So if you look at this first one, the default one that was there when I started, let's go ahead and click. I'm going to click on it, and I see that associated with this, it says there's a route table, a NACL, and all right. Well, what I'm actually thinking about is the subnets. So if I click on the, well, that's a little. I'll go to the subnets next. Okay. So just remember, this is 172.31.0.0.16. Go over to subnets, and I have two smaller networks that are part of that other one. So notice this is 172.31, and then everything after that can be manipulated. If I look here, 172.31, this says /20, and this is 16/20, and it gives us a little bit more information here. So from my original network, where I could, in theory, have 65,536 IP addresses, I've created 2 subnetworks, or carved out 2 portions of that network, which are available to use once I carve it into a subnetwork or create a subnetwork. And there's 4,091 here and 4,091 here IP addresses that can be used within that block. So I trailed off in my thoughts there for a second. What I was thinking about is the fact that these 2 different networks are located in, even though they're part of the big overall global address range within a particular region, they're technically in these little subnetworks get assigned a different group of data centers to be in. So within Northern California's region, there are a handful of different availability zones. I think that the options are A, B, and C. So they're physically distinct data centers. and or a grouping of data centers. And so if I were to spin up an EC2 instance and say put it in this particular subnet, then it's going to be physically located in this data center region. And if I say spin up my EC2 instance in this in this subnet right here, then if I select that while I'm launching my EC2 instance, then that EC2 instance is going to physically be set up in this other data center. Okay, so that's something about subnets. Other things that we'll kind of get more information about later on. We have a bunch of route tables here. I think that this first one right here, this one right here that has default on it, was probably the initial one that was there. The route table is, let me just select it there. The route table is something that supplies networking to a particular subnet. Routing tables are sort of like your own personal postal service for a network. And a postal service worker looks at addresses and it sends a letter to where it needs to go. So what we do is we assign a route table or a postal worker to a given network, and the rules that are within this thing called a routing table determine, based on traffic's IP address, what should happen with it. And in short, what we're seeing on this page is that anything that falls within the 172.31 range is going to be kept within the local VPC network, and anything that falls outside of this range, because there aren't any other, I could edit it and add more rules, but since there's no other rules, this is like the default rule. It says for anything else that doesn't fall within this range, this is kind of like the wild card, send it to this other service called an internet gateway. Basically send it out. That's another service we have running within AWS. It says send it out to the wild internet. All right, what else can we look at in here that would matter? Internet gateway. So this is just you don't have to think about this too much. This is just a service that we create and attach to our routing table so that there is a path to get out to the public internet. That's all that thing does. Seems like there's, let's talk about security groups. So over here in security groups are, that and NACLs are two different versions of firewalls. And if I were to look at one of them right here, here I have some inbound and outbound rules associated with a particular named security group, meaning a firewall rule that we can assign to like EC2 instances, for example. What this rule says is it's going to accept coming into an EC2 instance traffic only from the source which is actually itself. What does that mean? That means that only if an EC2 instance is using this, is kind of grouped together and using this exact same firewall rule, will it'll be able to talk to it. So nothing else matters. This thing is very restrictive. If I launch an EC2 instance and associate it with this firewall rule, let's just say I launch 3 EC2 instances and I give them all this firewall rule, then they can only talk to one another. They can't talk to anything else. So this firewall rule limits communication to them, but I could add in other things like, let's just say I wanted to do like, I want to allow HTTP traffic to come in, I could do that. And I would say I would allow traffic from anywhere on the internet to come in, and it can access instances defined by this security group rule on port 80. So that sounds a little complicated, but anyway, just a preview. Okay, and then there's another version of firewalls which are called NACLs. I'll talk about them later. It's just another, instead of associating the firewall with the EC2 instance itself, this is a secondary firewall that is considered to be optional, but it You can put a secondary firewall and put it around the subnetwork itself to restrict traffic in or out of the subnetwork. But like I said, it's kind of redundant if you already have that rule included in the security group that's associated with each instance. Okay, what I would like you to do is go over to your VPCs and take a snapshot of this page so I can see that you created a network of or a VPC of type development, production, and testing.